Okay, objective 164 is students will be able to factor and solve trinomials in ax squared plus bx plus c form when a does not equal 1. And go ahead and get that down. Alright, let's go on to the next page. Okay, the first thing when factoring, okay, we've learned several different techniques now for factoring. Okay, so let's review those because we're getting to the end of factoring. I want to make sure that you guys are putting all these different pieces in your mind together. So the very first thing is that we always look for GCF. Okay, first look for GCF. Okay. Second thing, and this is kind of the second method, we want to look to see if we can group. Can we group and factor? Okay. And then the third way that we've learned then, or kind of the final thing that we go to, is what we just call the AC method. Okay, and we're going to be practicing more of that today. Okay, let's get started with a few example problems. Okay, example number 1. Okay, make sure you have a good amount of room in your notes to do this. Example number 1. The directions said to factor 6x squared plus 17x plus 5. Okay. So if we look at this, right away the first thing that we should do is look for a GCF, a greatest common factor. And if I look at my A, my B, and my C, so my 6, 17, and 5. Well, 5 and 17 are both actually prime numbers. So unless both like 5 and 6 go into 17, okay, there's not going to be a common factor. So there's not a common factor to this one. Okay. The other thing to look at is, again, we need to write out our A equals 6, B equals 17, and C is equal to a positive 5. So the other thing to look at is the A, and if it equals a positive 1, we can almost use mental math and kind of use a smart cut to factor this. Okay, but when it's not, okay, in this case A is not positive 1. Okay, so we always need to look at that. So we're going to use the exact same method here, the AC method. Okay, so the first thing that we need to do before we even set up the table, let's think about the signs. What are the signs? So our answer, right, let's start with the end in mind. Our answer is going to look something like this. What are the signs of my answer going to be? Well, first we look here. Okay, I'm going to change color. Okay, first we look here. It tells us they are going to be the same signs. Now that I know they're the same, I have to figure out, okay, well, what are they going to be? Are they both going to be positive or are they both going to be negative? That's where I look next door, and I see they're both going to be positive. Okay, so that tells me that both of my factors, okay, are going to be positive. So I'm going to set up my table now. It is A times C, sum of B. Okay, my A is 6, my C is 5. Okay, and my sum, it needs to be a sum of 17. Okay, so 6 times 5 is 30, and again, it needs to be a sum of 17. So now what we can do is start listing out all the positive. Remember, both of these, the signs, and we can even kind of show it. I like to come down here and just write positive, kind of positive. That way when I'm thinking about my factors, the signs are like right there reminding me, okay, they're both positive. So let's start with the simple ones, 1 and 30. Okay, and you should kind of start thinking like these two numbers can't be really far apart from each other because they have to have a sum of 17. Okay, so 2 and 15. Let's see, what other factors do we have? We could do 5. Oh, I'm sorry, we have 3 and 10. 4, no, 5, and that's a 3. 5 and 6, okay? But right away, we should see these two right here give me that sum of 17, okay? So now, we need to rewrite it, okay? So we keep our first term, okay? We keep the 6x. Let me go to a different color. Don't have a lot of room to do these problems, so I'm going to try to squeeze this in. So I keep my first term, the 6x squared stays, okay? And then I'm going to write my 2x, because remember, this term and this term turn into the x terms, okay? So plus 2x plus 15x. And you guys, with putting the order of these, I could have switched the order, but I kind of see that 6 and 2 are both even numbers, and then I kind of see that 15 and 5, so then it'd be plus 5, right? And I kind of see that 15 and 5, they both, end in 5, so I know 5 is going to be a common factor. So I kind of think about the order that I put those, whether the 15x comes first, the 2x comes first. I try to kind of match them up. So now I factor by grouping. Okay, what's common to both of these terms? Well, I have a 2x common to both. So I'm going to factor out that 2x. That leaves me with 3x plus 1. Okay, what's common to both of these terms? Well, a 5 and a 5. So I have a 5 out there, and that leaves me with 3x plus 1. Okay, so now I just hug my GCFs, so my final answer would be 2x plus 5, and the other one, 3x plus 1. Okay. Now, if you finish a test or a quiz early, you can use the box method to double check that this goes back and actually gets you this exact same problem up above. Again, there's no reason why when you finish early, why you shouldn't check your answers to make sure that they multiply out, because again, that's multiplication, and get you the right answer. Okay. Let's go on to example 2. Okay, example 2 says to factor. Let's see, let's do 10x squared minus 43x plus 28. Okay? Alright, first thing I need to do is look for a GCF. So I'm going to start with 10. What are all the factors of 10? Well, 1 and 10, 2 and 5. Okay, does 10 go into 43 or 28? No. Does 5 go into 43 and 28? No. Does 2 go into 43 and 28? Well, it goes into 28, but it does not go into 43. Okay, so there are no greatest common factors that I can factor out of this right now. So that's, again, you always look for that. Okay, now we're going to write out A equals 10, B equals negative 43, and C equals 28. Okay, that's an ugly 8. All right. Now, is A equal to positive 1? And the answer is no. A does not equal positive 1. Okay, so we can't use a smart cut. So we know we're going to have to use the AC method on this. Okay, so let's first, again, determine the signs of our answer. Okay, so to do that, I'll give you a second. I want you guys thinking through what would the signs of the answer be. Okay, you should have realized that that addition here means that the signs are the same. Okay, and how do we know what they are? Well, once we know they're the same, we look next door, and that tells us they're both going to be minus. Okay, so we're going to have something minus something, and something minus something. So let's do the AC method now. So A times C, okay, sum of B. Well, A times C. So 10 times 28, so that'd be 280. Okay, the sum has to be negative 43. Okay. Now, whenever you're working with really big numbers, okay, I highly recommend that you do almost like we did with the factor cow, and you do the square root of 280 to see what you need to go up to as far as your numbers, right? Now remember, both of our factors have got to be negative, and we got that from right up here, right? Both of our factors have got to be negative. So take the square root out of 280 now. Okay, the square root of 280 is 16.7 something, right? So we would have to go up a long way. But let's start with just the simple ones, and we'll check the addition as we go, because hopefully we don't have to go up all the way to 16 or 17. So my first factors would obviously be negative 1 and negative 280. Okay, negative 2 and negative, what would that be, 140. Okay, does 3 go into 280? Well, 3 does go into, let's see, let me just do it. 280 divided by 3. The answer is no, so we don't need to put that. Divided by 4, it should, because 7 times 4 is 28. So let's see, we have negative 4. 280 divided by 4 then would be that 70, so negative 70. Okay, so again, I'm thinking of these as item. That'd be negative 281. That ain't it. That'd be negative 142. That ain't it. Negative 74. That ain't it. Let's see. It ends in a 0, so it should be divisible by 5. So 280 divided by 5 is 56. So negative 5 and negative 56. Okay, the sum of those would be negative 61. Oops. I'm getting closer to my negative 43, right? So I'm on the right track. Okay, 280 divided by 6. Again, some of these just take a little bit of work. 6 doesn't work. 280 divided by 7, that should work. Yep, 40. So negative 7 and negative 40. That gives me negative 47. So I'm getting really close. Let's try 8. 280 divided by 8. Let's see, negative 8 and negative 35. Because 280 divided by 8 is 35. Okay, when I add these two up, that does give me the negative 43. Okay, so when I rewrite this, again, I can stop there. I don't need to keep going. That's a waste of time to keep going. I just found my two factor pairs that multiply to get 280 and add up to be negative 43. So now I can rewrite them using the grouping method. Okay, so I would have, let's see, 10x squared. Okay. Let's see, my last number is going to be 28. I'm going to try keeping them in the same order. So minus 8x, we'll see if it works out. Minus 35x plus 28. Okay. Alright, now I can group these. Okay. So the GCF of these would be, let's see, what would be 2x, 2x, so 2x leaves me with 5x minus 4. And then the GCF of these would be, let's see, 7. But I know right now if I do negative 35 divided by a positive 7, that would get me a negative 5. And I see around this one right here, right? That's not a negative 5, that's a positive 5. So how do I get this to be a positive 5? I need to divide by negative 7. So I need to factor out a negative 7. So then when I factor that out, I'm left with 5x minus 4. Okay, and the signs match up now. So when I hug my GCFs, have my two binomials are 2x minus 7 and 5x minus 4. And you should always look, do the 2 and the 7 have any common factors I could pull out? No. Do the 5 and the 4? No. So I know that is my simplified answer. Okay. All right, if you have any questions, make sure you hit pause and write down your questions now. Otherwise, let's go on. Okay, let me flip my notes here. Example 3. Let's do factor 10x squared plus 80x plus 150. Okay. Alright, again, first thing that you should always do is look for a GCF. And this is really a good example of why you always want to look for that GCF. I mean, if you do 10 times 150, that would be 1,580, right? So you're asking yourself, what multiplies to get 1,500 and adds up to be 80? You are going to have a very, very long factor pair list, okay? So finding a GCF can help us avoid that. So if we look at this one, all of these numbers end in 0, right? So I know that a factor of all of these is going to be 10. So right now, before I do anything else, I can factor out that 10. Okay, factor out that 10. Okay, what's left? Well, you have to keep that 10 on the outside. What's left is x squared plus 8x plus 15, because those zeros cancel. Okay. All right. So now that I look at this, my a is now equal to a positive 1. My b is equal to 8, and my c is equal to 15. Okay. Now, before I go any further, I'm going to look at the signs, and whenever I factor out a number, I know that a common mistake that I do, and it's, again, you have to know your common mistakes. A common mistake that I do is I forget to write this factor in my final answer. So what I'm going to do is I'm going to come down here, and I'm going to write my final answer and actually circle it. Okay? And then whatever I figure out, I'm going to plug in to here. That way I don't forget that this is my answer with that 10 out in front. So again, when I factor something out, I know my common mistake is to forget about that in my final answer. So I'm just going to write my final answer now, and then I'll fill this in later. Okay? Now if I look at this, good. I think I can probably use mental math on this because a is equal to a positive 1. So I look at my signs. It tells me that they're going to be the same. Right? Now I look next door. Okay? They're both positive. So right now I can put in here, they're both positive. I can just write that in now. Okay? So I'm looking for factor pairs. And again, this is the mental math, right? Because a is positive 1. I'm looking for factor pairs that multiply. I'm just going to abbreviate. Multiply to get 15. And add to be 8. Again, this is what's going through my mind. So I'm thinking 1 and 15. No, they add to be 16. Let's see. 3 and 5. Yep, 3 and 5 is it, because 3 and 5 add up to be 8. So that tells me it's going to be x plus 3 and x plus 5. Okay, that's it. You're done. That's why it's so nice when a is positive 1, because you can kind of use the mental math shortcut on this. Okay, so this is my final answer. Now, if you want to check this, you would first multiply these two binomials using the box method, right? And then whatever you get for that answer, you would get an answer like this, right? It would be a trinomial. Then you would just distribute that 10 to check it. Okay, so that's how you would check that one. All right, so let's do, let's see, 2 more examples. So example 4 says to factor 2x squared plus 5x minus 2. Okay, so look for a GCF. Is there a GCF on this one? And the answer is no, there's not one, okay? Because 2 doesn't go into 5 evenly. So let's write out my A equals 2. My B equals 5. My C equals negative 2. Okay? A does not equal positive 1. So I'm going to have to do a little bit of work on this. So I'm going to have to do the AC method. Not a big deal. Okay? This right here tells me that the signs are different. Okay? Therefore, I don't need to look anywhere else. I know my answer is going to have something plus something, something minus something. Okay? Or, remember, the order doesn't matter with multiplication. You could put it like that. Again, doesn't matter. Okay? So let's use the AC method. AC sum of B. So my A and my C, 2 times negative 2, sum of 5. Okay? So it needs to multiply to get negative 4 and add up to be 5. Okay, so let's look at all the factor pairs that multiply to be negative 4. And I know the signs are positive and negative, right? So what multiplies to get negative 4? Well, I have a positive 1, negative 4. I also have a negative 1 and a positive 4, right? And then my only other factor pair are 2 and negative 2. Now, you could say, oh, negative 2 first and positive 2, but these are the same thing, right? You have a positive 2 and a negative 2, so you don't need to list that one at all. Okay, so if I add these up, 1 and negative 4 is negative 3, negative 1 and positive 4 is positive 3, 2 and negative 2 are 0. Huh. Well, that's interesting. Nothing multiplies or adds up to be 5. So when I think about this, okay, let me give you a few other examples to think about, right? When I said to factor 10 or write 10 as two different factors, you could have written it as 2 and 5, right? So that would be like factoring the number 10. What if I said to factor the number 7? What would you write there? Well, the only way that you could write 7 is 1 and 7, right? We said that 7 was a prime number. Okay? With this one, if you ever run into this, first of all, you should always double check your work, but I did. I double checked it. I did the signs correctly. I did the A times C correctly, sum of B. Nothing multiplies to give me negative 4 and adds up to be 5. Okay? So when that's the case, essentially what you're saying, you guys, is that you could not break this into two binomials that you could multiply to get this original trinomial. Okay? And again, you don't have to get all this down. I'm just explaining it. Okay? I do want you to get this down, though. Okay? Get that down. So the case with this is that we say that this trinomial is prime. This is our answer, okay? Because there are not two binomials that we can multiply to get us back to this original trinomial. Just like with this 7, right? The only two things that we can multiply are 1 and 7. It's a prime number. This is a prime trinomial, okay? It cannot be factored anymore. Okay? All right, 5. If it says, I'm not even going to write the directions on it. I'm just going to write the problem. And you should be, I'll go ahead and write. It'll say, most likely, it'll say to solve. So, is this saying to factor? No, it's different, right? Your answer needs to be a variable equals something. Okay? So, 8a squared minus 9a minus 5 is equal to 4 minus 3a. Okay. Now, right away, when you see this exponent of something squared, you should be thinking, well, I can't just solve this the way I do a regular equation. Okay. So what we're going to have to do with this is we're going to have to factor it first and then set our factors equal to 0. But before we can do that, we have to get, so let's write this key point, okay, must set equal to 0. Okay, well, how do we do that? Well, we got to get this positive 4 and this negative 3a to the other side. So let's move these to the left side. So I would subtract 4, and I'm putting those right underneath the 5 because those are like terms. And then I would add 3a, add 3a. Okay, so what's left? 8a squared minus 6a, and then minus 9. Okay, and that equals 0 because those all canceled, right? So that equals 0. So now I have to factor it. So I'm looking to see, is there GCF of 8, 6, and 9? And the answer is no. So I got to write out my A equals 8, B equals negative 6, C equals negative 9. Okay. Let's do the AC method. A times C, sum of B. Okay. Well, A times C, 8 times negative 9. Sum to get me negative 6. Okay. So I need something that multiplies to give me negative 72 and adds up to be negative 6. Okay. So I want you guys to go ahead and fill out this table and then rewrite it using the expanded form. So instead of writing the minus 6a, you should use your two factors to rewrite that to have 4 terms. Okay, so go ahead and fill out that table. Do the next step. Hit pause now and do that. Okay, here's what I got, and I started doing some, ran our room, so I just kept doing on my calculator, and I found my factor pairs are negative 12 and a positive 6, and together those add up to give me my negative 6. So then I rewrote them. Now, if you actually rewrote them to be 8a squared plus 6a and then minus 12a minus 9, that's actually fine. I think you're going to find you're going to get the exact same answer. So if your work right here looks a little bit different than mine, that's fine, but again, you should get the exact same answer. So my GCF of these would be 4a. Okay, so I have 4a. When I factor those out, I get 2a minus 3. And then my GCF here would be 3 and 3. So I have 3, and then I get 2a minus 3. Okay, now I got to hug my GCFs, 4a and a positive 3. Okay, and then my other one is 2a minus 3. Okay, now, and I already kind of started to do it. What do you have to do with both of these? Remember, this is solving, this is equals. So you have to set both of these equal to 0 and solve for a. When you do that with this first one, let's see, negative, you get negative 3 over 4. And again, you guys should sort of work for solving those. And on this one, you would get a positive 3 over 2. So then you write them in the brackets. You have negative 3/4. And you also have 3 over 2. That would be your answer to this. So if it has an equal to sign or it has to solve, okay, you have to make sure you do this last step and set them equal to 0. Okay, that's it. Make sure you complete the homework for this objective. And if you have any questions, which I'm guessing you will, make sure you write those down and come to class ready to ask those questions.